Hey guys, we are in the free online coaching classes for the NET examination. I took a long gap in preparing videos in this lecture series and I will try to do regular videos from now onwards in this lecture series. And this will be lecture number 15 and the topic of discussion is the submarine canyon. If you want to know what is a submarine canyon, its characteristic features, its formation and its economic importance, then this video is for you. Welcome to my channel Success Guru and myself Panchanadam, and let's get into the heading, the submarine canyon. Many deep gorges or valley-like trench cut mainly in the continental slopes, but some extend back into the continental shelves are known as the submarine canyon. So when we are discussing about the ocean floor topography, when we are moving from the continent towards the ocean, the first thing what we will reach is the continental shelf, right? Followed by the continental slope, then there is a continental rise, followed by the abyssal plain. So this is what the ocean floor topography, right? So in this continental slope, there are so many U-shaped or V-shaped gorges are there, and it may sometimes extend in the continental shelf also. And such a type of valley is called as a submarine canyon. It can also be defined like this: that is, a submarine canyon is a steep-sided valley cut into the seabed of the continental slope, sometimes extended well onto the continental shelf, having nearly vertical walls, can reach a height up to 5 kilometers. So this is what some other kind of definition for the submarine canyon. So let us see some of the characteristic features of the submarine canyon. The first one is that many submarine canyon consist of three distinct and interconnected parts. The first one is the shallow valley on the continental shelf. The second one is the deep rock-walled canyons or furrows in the continental slope. The third one is the broad shallow valley on the floor of the oceanic basin. So you can see here this is the shallow valley in the shelf, right? Then this will be the deep rock walled canyon in the continental slope. Then sometimes this canyon also extends in the abyssal plain, right? So this is how it can be subdivided into three different parts. There are worldwide in distribution and known to exist of all continents except in Antarctica. So almost in all continents the submarine canyon is present except in Antarctica. The third characteristic is that most canyons are seaward from the axial line of stream on land. Some can be traced across the continental shelf into the estuary of the river. Some submarine canyons bear no genetic relation to the stream on land. So this submarine canyon can be classified into two. That is, some submarine canyons can be extended towards the land stream. That is, it is in the axial line of the land stream. That simply feels like continuing towards the submarine, right? So there are submarine canyons just like this, and there are also submarine canyons which doesn't have any relationship with the land stream. So this can be like two different types like this. Then the next one is that deep canyons are intersected with furrows and ridges and seems to be restricted mainly to continental slope. So you can see in the submarine canyon, the middle portion that is in the continental slope, there are so many furrows and ridges there that is only restricted to this portion of the continental slope, right? The submarine canyons are of a recent geological origin. So by age it is recent, right? That is geologically. Most submarine canyons are cut in sedimentary rock, but not all, right? So most of the submarine canyons are formed in the sedimentary rock. They are found on submerged coast or emergent coast or mountainous coast, both young and old, or glacial coast and on deltaic and alluvial coast. That simply means that in all type of coastal landforms you can expect submarine canyon. They resemble canyons on land in V-shaped cross profile, great depth, sinus cores, rock walls, tributaries, etc. So if you are comparing a submarine canyon along with the land, stream, river valley, right? They too match in the case of cross-sectional profile, that is both are in V-shaped profile, cross-section. Their depths, right, and their path will be sinus like in the land stream, right? And the walls are rock, made up of rock, that is, it is due to erosion, right, as you know. Then there will be formation of tributaries. So these are the resemblance with the land stream along with the submarine canyon. And the difference are that there are significant difference in the longitudinal profile of the continent and submarine canyons. The thing is that the gradient of the submarine canyon on the continental slope averages about 10 times those of the land. So if you are comparing the gradient between the land canyon and the submarine canyon, you can simply see that the submarine canyon have a 10 times more gradient than the land canyon, right? And the last characteristic is that some submarine canyons extend seawards to a depth of over 2000 fathoms. As you know, submarine canyon is below the sea level. If you measure the depth, that is the deepest portion of the submarine canyon, that may reach up to 2000 fathoms. So these are some of the characteristic features of the submarine canyon. Now we will see the origin of submarine canyon. Okay. Many earlier theories stated that the canyon were of diastrophic origin and explained them as due to the faulting and local subsidence of the narrow block. So when we are discussing about the faults, like types of fault, right? So we have discussed about the in the extension region due to gravity there will be faulting that will form the graben and host, right? And these host, that is the raised portion, will look like a ridge, and the depressed portion, that is the graben, will resembles a valley. And as you know, this graben may always form a valley, just like our Narmada and Tapi river that flows in this type of fault valley, right? So this was considered to be the reason for the formation of the submarine canyon also, right? But there are some opposition. So let us see the reasons for the opposition. The first one is that if the valley is formed due to the faulting, then the valley path should be a straight line, right? But when you see a submarine canyon, you can expect that the sinus course of the canyon, which is not due to faulting, right? So this sinus path of the submarine canyon may not be formed due to a faulting, right? As it may be formed in a straight line. Then the dendritic pattern and the tributary have, right? So if the valley submarine canyon is formed due to faulting, right, then there will be no any tributaries as it is following in the valley itself. But when you see a submarine canyon, there are tributaries that resembles like a dendritic pattern. So that could not be possibly due to the faulting. So this is the second opposition. Then the gradient of the longitudinal profile. So if you see in the faulting, then the gradient will be somewhat equal or similar all along, right? But when there is a submarine canyon, you can see, as I mentioned earlier itself, the gradient of the submarine canyon is 10 times more than that of the gradient of a land canyon, right? So that could not be possibly due to the faulting. The presence in an area where faulting is not significant, right? So when they are talking about the origin due to faulting, there are also submarine canyons which is there where there is no any faulting evidence is present. Just like Atlantic coast, there is no any evidence of faulting, but there is also presence of submarine canyon. So this is also one of the opposition that is reason for the opposition. Then the trend in many areas that across the structure. So if there is a faulting, right, that will be continue in a straight line generally, right? So if you see the submarine canyon, there are submarine canyons which is crossing the regional structure, so that could not be due to faulting. So these are some of the opposition for the what do you call the diastrophic origin theory. So let us see some of the theories which has been raised after this theory, right? The first one is that it was suggested that they formed on a land and then drowned by downward or tilting, and this may explain a few of the causes. But as submarine canyon are known to exist off most coast, this explanation does not explain all. So the first one is that the first one theory is that the land was submerged or tilted after the formation of valley, and that leads to the formation of submarine canyon. But it is not accepted in many other places. Another subaerial theory assumed that it was the level of the sea that went up and down due to the changes produced by the glaciation deglaciation. As you know, when glaciation takes place, what happens? The mean sea level falls due to the maximum formation of glaciers, and when there is a deglaciation, what happens? The melting of glacier takes place, and that results to the rising of the mean sea level, right? As this glaciation desglaciation takes place in as cycles, that could be the reason for the formation of submarine canyon, as the mean sea level drops below the continental slope. So that was one of the theory. But the thing is that, however, the lowering of the sea level was not of the magnitude of several thousand meters. So if it could happen, then the sea level should fall thousands of meters down, but that is not possible due to glaciation. So this theory is also not accepted. According to Johnson, the submarine canyon might be formed due to the submarine springs sappings. Water from the Tertiary and Cretaceous formation below the coastal plain and the continental shelf would have developed enough artesian head and pressure to emerge as a submarine freshwater springs at the foot of the continental slope. The spring sapping would result in headward growth of the canyon up to the continental slope. So this is what the theory is proposed by the Johnson. That is just like in the landform there are springs, right? In the same way there will be springs in the oceanic basin. That is a freshwater spring at the bottom of the continental slope. And as the spring goes on, the headward erosion leads to the formation of a canyon all along the slope. So this was the theory proposed by Johnson. There are many objections to this theory that few give it serious consideration. It cannot explain the development of canyon in non-sedimentary rock, just like granite. So this theory cannot explain the reason for the formation of canyons in a granitic terrain where you may not expect formation of aquifer and a spring, right? So this example is that the Caramel Canyon of the coast of California is one of the examples where you can see a granitic rock with the presence of a submarine canyon in it. Butcher thought that the canyon result due to the seismic sea wave or the tsunami and current created by them down the continental slope. So this was his theory, that is the formation due to the seismic sea wave. But the tsunami are not very frequent. As you know, the tsunamis are not so frequent and are not operative all along the coastline. So you may know that this theory may not be accepted, right? The next one is the Daly suggests that the submarine canyon were cut by turbidity or suspension current, and that trenching of the continental slope was done by turbidity seawater with mud and silt in the suspension called the suspension or the turbidity current. Daly believed that the turbidity current were at maximum during the time of Pleistocene low sea level, when the shores were further seaward and the water over the continental shelf were loaded with mud and silt. Submarine slumping, sliding, and mud flow are believed to aid in the canyon cutting. And there is also a theory proposed by Landis argued that the reduction of the volume of the Earth's interior due to the shrinking globe has resulted in the sporadic but continuous sinking of the crustal segment, with the heavier oceanic segment being the first to drop. He claimed the oceanic basin might be differently lowered by as much as 6,000 to 10,000 meters, and thereby permitting cutting above the sea level of the canyon as deep as so far measured. So these are some of the theories that has been proposed for the formation of the submarine canyons. The theory that submarine canyon were cut by turbidity current aided by the submarine landslide, slumping and creeping of the sediment holds a slightly favored position today. So let us see some of the economic significance of submarine canyon. In a Neogen sequence of the Nigerian coast, oil was discovered in the canyon fill sediment. Similar traps will also be expected of in the Krishna Godavari Delta below the floor of Bay of Bengal. So with this I am concluding this submarine canyon, and I group my videos according to the category that you can check in my playlist. You can connect with us by mail, Facebook and Instagram, and these are the links. You can support us by like, share and subscribe. Thanks for watching. Have a great day.